Hello everyone, in today's video I will explain you what is upper and lower Darboux sum. And as you can see on these two formulas, it might be look very difficult, but it's actually really easy. So let me explain you. Suppose you have a function on some segment from A to B. This is our segment from x0 to x4. And there is function f of x which is bounded on this interval, and this is our partition. If you don't know what this partition is, I will remind you real quick. It's set of points on this segment where x0 is equal to a and xn is equal to b, and x0 is less than x1 and x1 is less than x2, and so on until xn. So as you can see in our graph, we have function f of x which increasing, and what is m small I? M small I is actually infimum of some interval, and this interval is denoted as xi minus 1 until xi. So for example, this is one of interval where we can find infimum, or this one is also interval, or this one is also interval, or this one is also interval. So what is infimum? As you can see, for example, if we took this interval, let's see our function, and our function is this is f of x. So the smallest point is infimum. So what is infimum? Of course it is this point, because it has the smallest value in this interval, and supremum will be this point. So I think it's pretty clear. As you can see, it's at the same interval, but it's the highest point, so this one is supremum. And let's see, for example, interval from x3 to x4. So infimum will be this point and supremum will be this point. I think it's really easy. So we know that m small I is infimum and m big I is supremum. So lower Darboux sum, or just lower sum without Darboux, we write as small s, which is the sum from I is equal to 1 until n mi multiplied by delta xi. So mi is our supremum multiplied by delta xi, our interval. So basically it is the sum of all rectangulars where we take high as infimum in any interval. So what let me write what is low Darboux sum in this graph. It's actually, look, it's all these rectangulars. It's all, sorry, my PC is little bit lagging, guys. I'm really sorry for that, but yeah. So this is set of these rectangulars, guys. Yeah, it is lower Darboux sum. And upper Darboux sum, it is also sum of squares of rectangulars, but we, in any rectangular, we take high as a supremum on each interval. So upper Darboux sum will be with this one, this whole rectangulars. This whole rectangulars will be upper Darboux sum. And really important to note that as small and as big depend only on partition tau. That means that how much points we take in our interval, and it's not depend on the choice of our interval, because supremum and infimum are unique. So how you can, so it is not depend, guys. I hope it's clear, especially on this graph, because without it it's quite hard to understand. But if you look at this, it's clear for you now. So I think I deserve like, and maybe subscribe, even if you won't subscribe to my channel. Bye bye.